Thank you, everyone, for joining us today. My name is Dr. John Frye. I'm a faculty member at UW-Whitewater. A little bit later on, you're going to be hearing from one of my colleagues, Dr. Compas, and one of his students, Passler. They're going to discuss a little bit about the future outlooks of climate change in the state of Wisconsin. But I'm here to kind of talk about where we've been in the state of Wisconsin and how climate has been changing. And we're not only going to look at Wisconsin, but we're going to look around the country because the big news stories this year have come from places other than the Midwest for once, which is, I guess, for us here, it's good. For them out there, it's maybe not so great. But again, we're going to kind of start big picture here, talk a little bit about how climate is changing around the planet, but then also, like I said, kind of focus here on the United States and here in Wisconsin. And so in terms of climate change, one of the biggest concerns that probably everybody on this call realizes is the warming that our planet has gone through over the last 100 years, and especially the very rapid warming we've experienced over the last 50 years, not only here in the US, but all around the world. So, very common graph. Everybody's probably seen something very similar to this. This is a graph of the temperature patterns on our planet over the last million years. This is put out by NASA. This particular graphic is from NASA. The different color lines on here represent just different ways in which we have gotten that data through different ice cores, ocean sediment cores, so we can recreate this timeline of those temperature patterns. Now, one important thing to keep in mind is that we as humans have only been here for a very small portion of this. Most of this climate change, most of this temperature pattern that we see here was due to natural causes. Things like the Milankovitch cycles, which is how our orbit changes around the sun, to natural changes in atmospheric composition. What is obviously a little more important and kind of what we focus on, a lot of climate scientists focus on, is this infamous graph from Michael Mann, commonly referred to as the hockey stick graph, if you've heard that term before. And this shows the temperatures over the last 1,500 years. Again, natural patterns in there at the beginning of this, some of this up and down pattern that we see of temperature. But again, what is of most concern is that the temperature patterns here in the last 100 years, and this has been due to anthropogenic reasons, us as humans, and the things that we are causing and changing about our Earth, which is causing climate to change. And, this rise in temperature that we've experienced over the last 100 years, 50 years, that timeline, that's important. But what alarms a lot of climate scientists, including myself, is the rate at which this has happened. So if we think back to that previous graph, we've had these these dramatic changes in our temperature patterns. However, when we're going and doing that in that previous graph, that's taking hundreds, if not thousands of years to do that temperature change. We have done an equivalent temperature change in less than 100 years. And that's what's alarming a lot of climate scientists, is the rate at which the temperature is changing on our planet. And so, we tend to focus on temperature, and, that's probably the easiest thing for us to measure about the Earth, whether we're looking at instrumented records or looking at proxy data. But that's not the only change that's going on. And that's what I want to spend a lot of time today talking to you about, are some of these other changes that are occurring on our planet. And so let's take a look at two different areas. We've got the dry desert area, we've got a vegetated area here. With that underlying warming of our temperature from a global perspective, that changes a couple things. And two big things that it changes is, number one, it changes the efficiency of evaporation off of the surface. So as it gets warmer, it's easier for us to evaporate water off of the surface. The other thing that warming does is it increases our capacity to have water vapor in the atmosphere. So not only are we increasing the efficiency of that evaporation, but we can also get more water vapor, get more of that gas up in the air. And so, as the temperature warms from a global perspective, we're taking these already dry areas and we're making them drier. We're taking those areas that have some lush vegetation, even over bodies of water, and that air above those areas is getting wetter or more moist. We're adding more water vapor. And so not only are we changing or having this change in our temperature patterns, but we're also then impacting our precipitation patterns. The dry areas are getting drier, and suffering from droughts. These vegetated areas, these areas near bodies of water are getting wetter because, again, we're putting more water vapor in the air. That allows us to potentially have more cloud cover, more precipitation. And so if we think about the US, and especially this year, which we're going to kind of go into some more details, in our dry areas, they have been suffering some effects from some very long-term droughts. In other areas of our country, we're seeing these record-setting rainfall events that are leading to flooding conditions. So let's start out west first. Places like California, and of course, one of the big news stories outside of COVID and elections and all that other stuff that we're dealing with when we're talking in terms of climate and weather this year. One of the biggest stories have been the wildfires out west in California. This is a picture from the LNU Lightning Complex fire in Lake County, California. More recently, there's still fires going on in California. They're not done. They're somewhat controlled. They're smaller than they were at their peak, a month or two ago. But more recently, Colorado has also been impacted by some wildfires as well. And this is a picture from the Pine Gulch fire near Glenwood Springs, Colorado. And so these areas out west, and this has been in the news, if you've even tangentially have paid attention to the news this year, you've heard stories about these fires. And the fires, we're going to talk about them, but one of the things about these fires this year is the amount of acreage that they burned, the rate at which they burned and spread was really, really extreme, really fast this year. There were some reports that one of the Colorado fire areas, we were burning 100 acres every hour. So there are these kind of major impacts that we're facing here. And this is related to climate. And so if we first look at here a graph that shows the amount of acreage that's been burned in the United States, which is the green line. So this is all of the United States territories. So not the, lower 48, Hawaii, Alaska, and then all of our territories around the world. We can see how the total number of acreages, there's this up and down pattern. There's really maybe a little bit of a trend line you could put on that, but been pretty consistent over the last 20 years. But if you look at California and Colorado, which are the blue and the orange lines, respectively, there on the bottom, we can see that the present year, 2020, they have set records for the number of acreage burned in those two states this year. And we still have 2 months to go. We're still in the peak area, our peak time period for wildfires. So again, these fires are still going on. They're still spreading somewhat, not as fast as they were, 2 months ago in California, about a month ago, a couple weeks ago in Colorado, but there are still some fires out there. Even at the United States level, I mean, we're kind of matching our highest peak. I think we're right below, I think it was 2015 was the previous year that held the record. And I think we're, probably going to eclipse that again with 2 months left here in the year. So how is this related to climate? One of the biggest factors in wildfires and the spread of wildfires is having fuel. And these drier areas, that, with this increase in temperature in these drier areas out in California, they are giving us more fuel for these fires to burn. So this is a timeline looking at the dry to drought conditions in the whole state of California. And you're looking at a percentage of the state that was classified as either abnormally dry up to exceptional drought in the various colors on here. And you can see for pretty much all of this timeline since 2000, some portion of California has been either abnormally dry or into exceptional drought. Probably the area that stands out the most is there 2014 to 2017. You see that exceptional drought, large portion of the state that was covered in that, and they really have not recovered from that. I mean, they're still dealing with the consequences of that drought, the dry vegetation that's still littered on the ground. And again, that's providing fuel for these fires to spread. If we look at just Northern California, the San Francisco district, and these are from the US Drought Monitor, and so they have these different districts that they break out. So San Francisco covers pretty much the northern, I'd say about third of California. You can see that same pattern emerge. And this is where a lot of those prominent fires that have occurred this year have happened. And again, even going back to 2014 2017 timeframe, that exceptional drought kind of left these lingering effects that are now adding fuel to these fires. So some of the fires were started by humans unintentionally. Some of these were started by storms, lightning strikes. So various ways in which the fire started, but because we've had these drier conditions, that has added more fuel to the areas. And we see the same thing in Colorado. So looking at Colorado as a whole, again, since 2000, very little time period that at least some portion of Colorado hasn't been in that kind of dry region. And then going down to the Albuquerque district, which covers New Mexico and then up into Southeast Colorado, again, the same kind of story going on there. So again, out west, we've been dealing with these drier conditions, leading to more fuel for these wildfires, allowing them to spread very quickly in these areas. And again, we're seeing the consequences of that over the last couple of years, and especially this year. So what about Wisconsin? What's going on here? We're kind of on that flip side. We're in an area where, if climatologically speaking, we're, those vegetated areas, we've got some good moisture sources nearby. And so we're on the opposite end of the spectrum. So, I've been doing a lot of research on the precipitation patterns in Wisconsin and pretty much the upper Great Lakes region, Michigan, Minnesota as well. And we're seeing a story here where whether we look at trend lines, whether we look at difference of means, like you're viewing here on this map here, we have seen an increase in the amount of precipitation that we are receiving. So these are annual values. So from the late 1800s, early part of the 1900s, which was the first 30 years of instrumented record that we have for the state of Wisconsin, to the most current, the recent 30 years, we've seen an increase across the southern part of the state of upwards of 5 inches of increase in precipitation over that about 100 year span there. And so again, we're seeing these more precipitation, so we could potentially be influenced in having more flooding events with this. Again, I've done a lot of research and worked with some students researching this. And not only are we seeing an increase in the precipitation, but at the same time, we're seeing a decrease in the number of days in which we receive precipitation. So we're seeing amounts go up, but the number of days go down. So we're actually getting more precipitation in fewer days. So we're having these larger precipitation events. And again, when you get a lot of precipitation at one time, this could lead to potentially some flash flooding issues. And we're seeing this not only across the state of Wisconsin, but again, extending over into the the stations that we've looked at in Michigan and Minnesota as well. Again, we're still in the middle of this research. We're also looking into, I've been working with another colleague that is interested in flooding. And so we're looking at flood declarations across the 3-state area to see if those have increased because of these, what we're calling extreme precipitation days, have occurred here in Wisconsin. So we're, California, Colorado getting drier, we're getting wetter here in the Great Lakes region. And a good example of this from this year was, for the first time ever, we had a tropical cyclone that moved through our area, and it brought us one of these heavy rainfall events. So back on beginning part of June 9th to June 11th, we had what was Tropical Storm Cristobal move through the state. And what you're looking at here is the rainfall, the 24-hour rainfall totals from Tuesday to Wednesday on the left, and then from Wednesday to Thursday on the right-hand image. And again, you can see out in the western part of the state, over near the La Crosse area, we had, upwards of 3 inches of rain across portions of the state. We saw some smaller pockets on that second day from this. And so again, this is just one example of these extreme rainfall days that we have been experiencing. This was kind of a unique situation this year with Cristobal moving through our area. Now, not only was Cristobal causing a lot of precipitation, there was also a lot of wind gusts associated with this. Again, this storm stayed tropical in nature all the way up into the Great Lakes region. It's the first time that this has happened, at least for the state of Wisconsin. So we had these high wind measurements as well. We also set records for the lowest pressure recorded in the state in some areas as the cyclone passed. So, there were a lot of other effects besides just the precipitation here. And again, this just shows you the path of Cristobal here. Again, it still had its tropical characteristics as it moved through the state, and that's the first time since this database that was used to create this map goes back to the 1850s. We've had some other storms, but they were already transitioning into what we call a post-tropical storm. So they had lost their tropical characteristics. You can see one there in 1900, 1949, and then Gilbert back in 1988. So we had some remnants of cyclones move through, but never a storm that still had its tropical characteristics. And that was brought about, again, very warm. We were experiencing some warmer temperatures. There was a lot of moisture already in the ground with a very wet spring and early summer throughout the Mississippi River Valley. So it allowed this cyclone to keep its intensity even as it was moving over land here. And Cristobal was just one storm from this year. And we have actually, within the last week, we have now set a record for the total number of tropical cyclones in the Atlantic. We broke the record this past week. We've had 28 named storms, and you can see those mapped out here with the different stages and different categories there of hurricanes that we see. And we still have a month left in the traditional hurricane season, and about just a little over 2 months, that we've seen storms before. We've seen some storms develop late December and extend into kind of mid-January. So we still have some time to go to increase this lead on this record that we've already created this year with these 28 storms. And again, just kind of zooming in here to the Gulf has been very active, including our most recent storm, which we're going to take a look at here in just a second. But the Gulf Coast states, especially there in Louisiana, you see the two paths cross of the Category 4 and the Category 2 storm hitting about in the same vicinity there in Louisiana. So, this part of our country has been reeling from these tropical cyclones, hurricanes moving through that area, and have felt the brunt. Again, this is our record-breaking storm. It's still going on. This is the forecast for the next couple days. I pulled this down just after noon today. So this is of Tropical Depression Eta right now. It is supposed to intensify back up into tropical storm strength. That was a hurricane as it cut across Central America there, did quite a bit of damage there in Central America. And now it's moving back out to the Gulf, and we'll have to see, this takes it through Wednesday of next week, but the Gulf is still really warm right now, so we could potentially see this intensify back up into hurricane strength, and it make landfall here in the United States as it curls back up to the north there. So our season's not done. And again, just to kind of look at timeline of the number of storms that we've had in the Atlantic. So our storms the total number of named storms have been on the increase. It's a little bit harder, a little bit smaller amount of hurricane increases and major hurricane increases. And again, we're looking since 1950 here. But again, it's been a very active season, and we've seen a lot of active seasons over the last few years. And not only have these seasons been active, but again, from this idea where we have these warmer temperatures globally, we're getting more water, we're getting more moisture up into these storms. And so the rainfall that has come from these storms has been a lot higher than it has in the past. One way we can measure kind of the intensity of these cyclones is to look at what are called ACE scores. ACE stands for Atlantic Accumulated Cyclone Energy. So it's a way in which we can measure the total amount of energy from all of the hurricanes each year. And again, we're looking 1950 through 2020 so far, and we can see there is a slight increase in those ACE scores if we had put a trend line on that. But especially if you kind of take pre-1980s and look at pre-1990s, I should say, and look at the records. If you kind of look there, you'd see a lower kind of mean ACE score compared to the most recent 30 years here. So again, warmer temperatures leading to these higher amounts of evaporation off of the surface, leading to these stronger storms, leading to more precipitation in areas that are already wet, while out west, again, those drier areas are getting drier. So far this year, we've been pretty lucky here in the state of Wisconsin. We haven't had any kind of big weather events that have impacted us. We did have the, derecho in the middle of the summertime, but that impacted Iowa a little bit more. We barely got clipped by that. So we haven't really had any big news in terms of weather events this year in Wisconsin. I'm not trying to jinx us or anything, but we haven't. So I wanted to kind of talk a little bit about some of the other areas around the United States that have been feeling these impacts of weather events, and again, how climate change is playing a role in those. But for now, what I'd like to do is introduce, again, my colleague, Dr. Eric Compas, one of his research students, Eric Passler. They're going to talk a little bit about kind of looking into the future and some climate change projections for the state of Wisconsin, and how that's going to have an impact on some societal things that we deal with here in our state. So I guess I will turn it over to them. And I think we're going to do questions at the end, if I remember correctly, Ashley.
Either way, I think we could stop for a few minutes, and if anyone has a question now, feel free to unmute yourself or drop it in the chat for Dr. Frye.
Yeah, I have one quick question, Dr. Frye. Is there any way to harness the energy produced from the ACE scores?
As far as like to create energy or anything like that?
Correct.
The issue would be, the first thing I think about, one of the first things I think about when you're talking about tropical cyclones is the wind. The problem with the force of the wind is so strong in these storms that would be hard to be able to kind of capture that at least with the technology that we have today in terms of, windmills and features like that. There are some methods out there that are collecting wave action. Those, again, this is newer technology, so I don't know a lot about it, but that may be able to stand up to those changes that occur in the oceans due to tropical cyclones. The problem with that is you would be then rooting for more landfalling hurricanes. So that may not be the best, because these devices have to be close to, somewhat close to the coastline. So you're not running this tremendous amount of cable to get that energy, to where it can be used. So yeah, you could probably capture the energy, but do you really want more and potentially stronger hurricanes making landfall in areas to produce that? So, technology wise, I don't think we're there to be able to harness any of that energy. But that's what you guys are here for, right? You're going to solve those world problems and come up with those things to allow us to do that in the future.
Great, thank you.
I had one question, Dr. Frye. I know you talked a lot about like the intensity of the seasons, and that was very eye-opening. I'm curious if there's been any changes to like the duration of those seasons, like I guess specifically hurricane season. Have there been any changes with duration, I guess?
I mean, this year, yes, we had a pretty early start to hurricane season. I mean, traditional, if we think traditionally, climatologically, hurricane season goes from June 1st through the end of November. We had some storms develop in May this year. Obviously we'll have to see kind of how this season goes, but in the last I'd say 10 years or so, we've had a higher number of storms starting earlier, that May timeframe. And we've had a lot of storms that have happened in December, even extending into January. If you go back, I think 2005 was the last time we had a storm season extended to January, if I remember. We may have had one season between then and now, but so we have seen an increase in that season. And the other thing I didn't mention is, we just looked at the Atlantic. The Pacific has been extremely active. I mean, if you look at hurricane occurrences in the Eastern Pacific between, Hawaii and mainland US, that has been on the rise. If you look at the typhoons in the Western Pacific over by Asia, those are on the rise. If you look at the tropical cyclones in the Indian Ocean, those have been on the rise. So it's not just the Atlantic that's seen this increase in the number of storms and the intensity of these storms in terms of, things like ACE scores and precipitation amounts. We're seeing this all around the world. So, and their seasons are slightly different, but again, we're seeing those same patterns, those same increases in those areas as well.
Thank you.
Any more questions for John? I'll go ahead and start sharing my screen here. All right, can you guys see that? All right, well, my name's Eric Compas, and I'm also from UW-Whitewater, from the Department of Geology, Geography, and Environmental Science, and I'm here with Eric Passler, an undergraduate student from the same department.
Hello, everybody.
And this is gonna dovetail really well with what John talked about, and kind of setting the stage for what we think is going to happen in the future. So we're going to give you a glimpse of future Wisconsin for free, and what that might look like, and hopefully give you an idea of what that'll mean for, in particular, some cultural and economic practices in Wisconsin. And again, I'm not going to go over what John talked about, but most of you guys are already aware that there's plenty of evidence that climate change is real. We keep breaking these records. The hottest month, the hottest year, the hottest season, and that with these catastrophic events that are occurring out west, the fires in Australia, the fires in California, Colorado, hurricane season, that a lot of the globe can likely, if we start asking people, do you feel like you're personally experiencing climate change? You will get yes in some of these places. And then here's Wisconsin. Everything's still like right on schedule, so to speak. And I guess right now we got some really nice weather outside, but we tend to get this kind of Indian summer. But fall looks pretty much like it always does. And probably started asking people in Wisconsin if they think climate change is happening here. Quite a few would say, no, or I don't think so. So we wanted to look at climate change models and get some idea of when will people in Wisconsin probably feel like it's impacting their lives in some way. And we're going to do two takes on this using some downscaled climate change models. We're going to look at agriculture, in particular corn production and potential declines in yield. And then Eric's going to talk about his project on winter recreation. So we're going to cover a little bit about downscaled models. What are they? How do we get access to them? How do we use them? And then those two glimpses. And just an aside, all this work has come from either teaching or undergraduate research. So I've in a class, we tried to figure out how to get access and to use these downscale climate change models pretty successfully. And then two students, Eric, who's speaking today, and Pablo, who did some undergraduate research that I'm borrowing to present here today. So a little bit about these downscale climate change models. Most of you realize that we hear about future projections, that these are these global circulation models. Research centers around the world use supercomputers to come up with these projections of what future climates will look like, roughly about 100 years out for a variety of different future climate change scenarios. And that's what I'm showing here on the left for Wisconsin. And when you start looking at a particular place like Wisconsin, the scale at which these are done make them difficult to get an idea of how that climate will particularly impact a place. So the average temperature in this grid cell might be 90 degrees on some day in summer. But in reality, that means some parts of that grid cell are going to be much hotter and some cooler. And so this gives an average, but it kind of misses out on the extreme events, extreme cold, extreme hot, extreme precipitation. And that's what people are going to feel, those extremes. So in order to get a glimpse of what that would look like, there's a variety of different downscaling techniques. We're using one of those called the localized constructed analogs, or LOCA. We did not create these downscale models. This is done by Pierce et al. And a variety of different teams that have put together these types of downscale models. What they do is they try to find, with this local model, is they look into Wisconsin's climatological past and try to find a day that looks similar to the modeled day. So if you imagine this is June 13th, that's what the global climate change circulation models are predicting. And so they go back and they look for a day that matches that as closely as possible. So taking something from our climate past and getting an idea what it will look like in the future. So those are the analogs. And that's how we get our downscaled models. And that gives us a better glimpse of what those extremes might look like. The use of these downscale models comes with a big caveat. Those, obviously, this is a stochastic process. These models have a lot of variability. So it's inappropriate to look at a specific city or place on a particular day and say that this, of course, is going to happen. But it will give us some sense of the trends through time and the trends through space in the state. They also, it's hard to kind of characterize the variability. So as we look at these maps, imagine a spatial kind of error bar around the data that we're going to give you. Okay, so that's our downscaling. Well, actually, I've got a video here. This is what 1 year of data looks like. So this is a quick video showing what we're actually working with in the GIS. So this is 365 days of the local model. And imagine using an algorithm that can take each of those days, and maybe we're interested in the number of days where the temperature gets above 100 degrees in urban areas across the state. And we can use the GIS to tally up the number of days that we might have a heat wave in Milwaukee or Madison or Eau Claire. And we can ask other questions on low temperature, precipitation, and so forth that people are likely to experience. And that's what we've done for these different takes. Of course, there's different modeled futures. And so we're drawing upon the Intergovernmental Panel on Climate Change 5th report that used 4 different modeled futures. So this is kind of a range of different levels of CO2 in the atmosphere. These are called representative concentration pathways, or RCPs. The most optimistic is this 2.6 kind of dramatic reductions in CO2 emissions. Definitely not on that path. The RCP 4.5, this is kind of a moderate reductions. It's the closest that matches to the Paris Climate Accord if all countries stay part of that and participate. And then there's 2 more extreme scenarios. There's 6.0, and these labels are mine. They vary depending on who's talking about them, which would be minimal reductions, probably a little bit more rosy than we're on right now. There's a problem with this model that a lot of researchers don't use it though. So a lot of research ends up using this doomsday scenario, kind of an ever increasing CO2 emissions is 8.5. So for what we're going to show you today, we're going to match these 2. We're going to use these RCP 4.5 and 8.5. So our first glimpse, looking at a key economic part of the state, corn production, worth by itself, corn, $2 billion in 2018. That's obviously used for other economic practices in the state, dairy production, cattle production, which is worth several $1 billion. So anything that might threaten that would be a significant impact to the state. Corn, while it's a fairly robust crop, is susceptible to heat in a couple of stages during its life cycle. It can't take days more than 95 degrees while it's during pollination. It'll kill the pollen and therefore the corn kernel won't form. It's also, it sees reduced yields in warm summer nights. And as you get close to warmer temperatures in general, reduce yield. And as what we're showing in the graph over here, as the average maximum temperature in July increases, the attainable yield is lowered. And so this is actual measured empirical data from Illinois corn production. And so we're going to use the same curve here, that regression line that we've placed across that data, to look at potential yield declines moving forward. So we're going to take that data that I showed you, that local model, and ask what's the average July maximum using both those RCP 4.5 and 8.5s, and then interpolate what that would mean for corn yield. So here's one of those slides that has way too much information on it. So let's take a moment to figure out what we're looking at here. So we've got our time series. So first of all, we're looking at RCP 4.5. So this is that Paris Climate Accord projected future. We've got 2020 all the way up to 2099, the extent of the downscaled data. This kind of green haze that you see is the area in the state in which we produce corn. So that's all the places where we grow it. And then we can see with that average high temperature in July, how that goes up through time. And for this time series, the worst of our decades is 2080. So it gets worse up to 2080 and then actually starts to improve in 2099. Down here to the left, we've got a graph that shows that mean temperature for the green area, for the corn growing area of the state. And as you can visually see, the mean temperature increases, the lighter blue lines are the min and max, until we get up to 2080, that our mean maximum temperature is about 89 degrees Fahrenheit. Now, if we go back to our curve, our empirical curve, that would yield about a 20% reduction in corn yield by 2080. Now, if we compare that to the RCP 8.5, that more kind of doomsday scenario, things look much worse. So they tend to follow a similar pattern and then just go from bad to worse, where we end up at 2099 into potentially something that's unrecognizable, not a state that any of us were born or raised in or live in. So we've superimposed both those curves down here. Again, for the corn growing area, we end up by 2099 of that mean maximum temperature being close to that 95 degrees that doesn't allow corn to pollinate. And again, extrapolating based upon empirical data, about a 50% decline in corn yield. So if you can think about what that might mean for the future growth of corn, we could probably use genetic modification, adaptation procedures to probably keep corn growing in this Paris Climate Accord future, but probably not in this RCP 8.5. All right, I'll hand it over to Eric to talk about the work on winter recreation.
All right, hello everybody. Like Dr. Compas said at the start of the presentation, my name is Eric Passler. I'm an undergraduate research student and a current student on geography and environmental studies over at UW-Whitewater. And over the past year or so, I've been conducting research on the potential relationship between winter recreation and climate change in the state of Wisconsin. I'm sure as all of you most likely know, being in Wisconsin, winter recreation is a huge part of our economy, our tourism draw, and just our cultural imprint, kind of something that we have become known for through events like the American Birkebeiner, through other snowmobiling events. We're kind of that hub, along with states like Minnesota and Michigan, for winter recreation in the Midwest. And so we really wanted to analyze how that might be affected. And we did this primarily through two different approaches. One was a survey. We sent out a survey to every single Wisconsin state park, forest, recreational area, as well as every county in the state of Wisconsin. So it was 153 total surveys distributed. We got about 83 back, which is a 54% response rate. And what this survey really encompassed was asking questions regarding winter recreational events, activities, and some mitigation and adaptation strategies of these land managers. These questions were all regarding the past 10 years, and a number of them asked questions about these land managers' anticipated changes for the upcoming 10 years. And for all these, we focused on what the winter season was going to be defined as, what we defined it as, so kind of that season that we call winter. We are able to partake typically in these winter recreational activities. And what that is the entire month of December and then January through March. So again, it's kind of that standard definition, and really the number of days that are at or below 0 degrees Celsius at that freezing point or below. And that's really where the GIS analysis came in. And so we used the local downscaled climate models that Dr. Compas covered in depth. We focused on RCP scenarios 4.5 and 8.5. And we utilized 10 regional GCMs or global climate models to isolate that data. And these 10 were specifically chosen out of a number of them because we thought that they would best fit the Wisconsin region. They would best fit the general greater Great Lakes region. And we actually figured this out along Dr. Compas and myself, along with Dr. Frye, who just presented earlier. And so those were the ones that we really felt would fit the distribution the best and would fit the data the best. You can see on the right here, there's this zonal map of Wisconsin that was created. And what that map does is split up the survey respondents into 3 distinct zones. There's an even distribution of survey respondents, so those land managers in each zone. It allows us to kind of generalize and look at analysis in a general proportion without isolating one specific park or county and revealing any of their information. We can look at the whole chain throughout an entire region of Wisconsin together. So focusing on the survey results, the first 2 graphs that I want to show you here are going to be on the number of days available to cross-country ski. And this was one of those questions where we asked about the past 10 years and then as well as the upcoming 10 years. So the way we phrased the question to the survey participants was, what is the estimated change that you have seen in the number of days available to cross-country ski over the past 10 years? And then what are you anticipating over the next 10? And you can see on the graph over on the top left corner, the way it's set up is the total number of days is rising, or the total number of participants who answered the question in the bucket that you see on the x-axis. So for on the y, it is split into those 3 different zones. So you can see zone 1 is that redder color, zone 2 is the yellower. Those are those central and southern parts of Wisconsin. And a lot of those land managers notice that there has been a decrease in the number of days available to participate, just what they've seen in their county or within their park, within their jurisdiction zone. And the magnitude of those, especially in the southern part of Wisconsin, is pretty great. There's some answers over in the greater than 50% decrease in the number of days available. So to them, it appears that they've lost about half of their season or about a quarter of their season or so. And that's kind of what has been seen across the board. Zone 3, not so much in the northern zone. A lot of them have actually answered that they've seen an increase in the number of days available or no change. And there is always a pretty high concentration in the responses saying that there's been no change. If you look at the anticipated change in the upcoming 10 years, though, you see something pretty similar to the first graph, if not more drastic. There are more people in zones 1 and in zones 2 that are anticipating a greater change and a fewer number of days available to participate in cross-country skiing in their jurisdictional zone. And even some areas from zone 3 are starting to see those same results, dropping down to an 11 to 25% decrease in those northern parts of Wisconsin and their parks and counties. And so everybody kind of across the state is expecting, based off of past experience and just what they're expecting to see, that there's going to be fewer days available to cross-country ski, and that the general season available to the public is going to become shorter. And then two of the other parts that we focused on were mainly on winter recreational events. So where the activities is just any day that you can go out and cross-country ski, you're not participating in anything. These events are going to be pre-planned activities. So for example, like the American Birkebeiner before. And you can see in terms of event cancellations, which is that graph up on the top left corner, it's sort of exactly the same as the other one. The difference here being if there is an increase, it means that they have seen an increase in cancellations of events that they have held or they have organized. Once again, a very similar trend. The central and southern parts of Wisconsin are there seeing a much greater increase in needing to cancel the events they have planned out that they were planning on holding. And again, in a lot of those cases, some of that greater magnitude, looking at over a 26% increase in event cancellations over the past 10 years. This is even more true in event postponements. There's nobody who answered this survey that said they have seen a decrease in postponements. It has either been no change or they have seen an increase. And while it is, again, mostly concentrated in zones 1 and 2, there are still people in the northern parts of Wisconsin that are saying, yeah, we've been postponing events more often. These warm weather conditions are just not staying out of the way. We are having to push these events back because we'll plan something out for early December, and all of a sudden it comes up and there's no snow on the ground, or it's not nearly cold enough to hold these events. The snow is melted right away if it did fall. And so they're just having to push these events further and further back throughout the winter season. The question becomes, if this continues, how far back can you push them back before they do just end up getting canceled? And that's what a lot of those qualitative responses said. They said we started off postponing, and now it's gotten to a point where it's just not worth it to keep postponing events, and we are outright canceling them. So that kind of sums up most of these survey responses that we got. Looking at the GIS analysis, I ran something very similar to what Dr. Compas showed earlier with corn. What these maps are showing, they're split up into those zonal maps overlaid on top of the data. The colors that you're seeing on there are the percentage of days in the winter season that were at or below 0 degrees Celsius. So at or below freezing, where precipitation falls, it can be snow on the ground. So the bluer color means that a greater percentage of the winter season is experiencing those criteria. The red or orange colors are saying that there's a smaller percentage of the winter season that's going to be at or below freezing. And you can see it does really start to get more intense over in 2099 with a much redder yellow-orange rim kind of around that southern part of Wisconsin right there. And you can see the graph down below shows the exact same thing there. It starts off all three zones, regardless of where they are, well over 100 days in the winter season that are going to be at or below 0. And zone 1 by the end, by 2099, is just above 80 days in the winter season. So you're losing a significant amount. It's a 25% decline in the number of days at or below 0 in zone 1 by 2099. So again, this is RCP 4.5. This is kind of that Paris Climate Accord scenario. Looking at RCP 8.5, it becomes even more drastic. You can see there's a definite color shift, especially around 2099, that still being the worst year. There is a very distinctive red, yellow, orange outline and rim throughout the entire eastern border of Wisconsin, and especially down in the southern corner, down in that southeastern corner, kind of right where UW-Whitewater is, Milwaukee, Waukesha, that whole area. If this scenario holds true, is going to see a very large impact on their winter season. It bumps up to a 30% decline in the number of days at or below 0 in zone 1 by 2099, dropping all the way to a decent below 80 days in the winter season. That's going to be beating those criteria. And so there definitely can be an effect, and it's projected to have an effect where there just simply won't be the same number of days at or below 0 where you can have snow conditions, where stuff can stay frozen on the ground, and that will allow people to participate in these activities and events. So what does this all mean for Wisconsin? I talked about earlier, a huge part of winter recreation in Wisconsin is the economy. It brings in a lot of tourism for some of these larger events, and it is a cultural staple, not only nationally and internationally, but for us as well here in Wisconsin. I'm sure all of you have participated in some form of winter recreation at some form in your life, even if that's just going out and snowshoeing or going on a hike in the snow somewhere. All that has the potential to be affected because there is a clear correlation between climate change and winter recreation. It's a change that has been noticed by these land managers that are directly involved with all of these planning activities and events. They're anticipating a greater change. And something I also want to point out is we did not specifically look at the continuous days at or below 0 degrees Celsius for an entire winter season. We picked out the total number of days. So what that means is that even if snow falls and it does stay on the ground, we are not looking at the continuous number of days that's going to be below 0. So it could fall, and then there could be 3 or 4 days where it is well above 32 degrees Fahrenheit, and that snow has the potential to melt. And so then you're really looking at, 1 day, 1 to 2, 1 to 3 days in a week that are separated where you can participate in these activities and events, not an entire week blocked out potentially. So that could be an even greater effect. And this is something we're looking into as well. We are planning a more in-depth report, running a number of more models, focusing more on precipitation as well to kind of connect what Dr. Frye was talking about earlier. And if you would like to see that report when it comes out, please feel free to contact me. My contact info is at the end of this presentation. I'd be happy to provide you with that as well. And then I'll turn it back over to Dr. Compas.
One of the things that this analysis shows is that there's still a significant difference between these different futures. So as we think about the Paris Climate Accord, and some people kind of respond, well, let's just switch to adaptation or geoengineering. We're kind of done. We've screwed up. That these models show that there's still a significant latitude for picking futures that are much more easy to adapt to versus ones that are a complete state change and mean a different Wisconsin and a different country. So it still does matter which path we're on. Unfortunately, if we look at the data so far since when the IPCC fifth report came out, our emissions are tracking closer to the 8.5 than they are, of course, to the 4.5. So we are not heading in the right position. So stepping back just a little bit, we've been in this study, particularly with the winter recreation, thinking about cultural phenology. So in biology, they're tracking when birds migrate, when they establish nests and so forth. And we assumed that we could easily collect a lot of records about when these events were canceled, when they were held, and so forth. And what we found in particularly the preliminary studies is that data is not being collected in a way that's systematic, that we can use to really identify changes in cultural practices. So we switched to the kind of more qualitative look at this, their sense of the change, instead of actually measuring the difference. It's only events like the Berkey Beaner where that really strong record exists. It's clear that Wisconsin is already feeling climate change, not the same way that the Coloradans or Californians or Australians are with the fires, and Louisiana with hurricanes. But people are already noticing, these land managers are already noticing. In the qualitative stuff, some of the stuff that Eric didn't talk about is that adaptation, there are possible options that are already being considered, planting trees, changing events in order to still have winter recreation occur, even though it's warmer, just to keep the snow on the ground. And again, big picture, thinking about we've heard about the frog in the slowly boiling water, is that there's a psychology of a slow crisis that's unfolding right now that isn't triggering a public response that we need to do something about this now in Wisconsin. It may make it difficult to get the public to pay more attention. So with that, well, we're finished, and we certainly entertain other ways to analyze this LOCA data, potentially stuff that's relevant more to the sustainability questions that you guys are addressing on different campuses across the state. So thank you very much.
If anyone has a question, you feel free to unmute yourself. Otherwise, if you're shy, drop it in the chat and I can read it off.
Oh, that's Samantha.
Yeah, hi.
Thanks. Yeah, fortunately, I had to miss the first part of the presentation. But a few years ago, I had students in one of my climate classes collect snowfall data for major weather stations from around the state, and just basically do a real simple linear regression on snowfall amounts. And we actually found in most cases, except the most southeastern portion of the state, that there's been over the length of weather records. I mean, some places, back 100+ years, other places not as much, but an increase in snowfall over the length of record. And I mean, it doesn't address the fact that, well, you might get dumped on and then it melts 2 days later, which is certainly a problem that, will likely happen more and more. But the other thing we ran into is we were looking at some of these downscaled models from Wisconsin and the upper Midwest region, a series of ones, and they all sort of aggregate the data by season. So you have December, the DJF is December, January, February, and the sort of predictive models of what's going to happen over that time period. The problem is that the most snowfall is usually shifted a bit to January, February, March in Wisconsin. And what I've noticed from like the outdoor recreation industry is that I've actually been involved with is that there's sort of this shift to, more out, especially, in the southern half of the state, things like bicycling and other forms of recreation earlier, whereas with the trend and the seasonality of snowfall, maybe many of these organizations or events could push their dates later into the season. Anyway, just a few observations, but thanks again.
Yeah, some comments on that, Samantha. We realized that the models were predicting more precipitation in winter. And so that we kind of expected, and we see this a little bit in that zone 3, that there's the increase in precipitation has led to more snow and an increase in their ability to hold some of these events. But in the south, that precipitation, that total snowfall may be increasing, but as you indicated, that it may not be staying on the ground, that it snows and then we get a warm spell, it melts. And so you don't get the accumulation that we used to get, like if you're a skier, the amount of base. And so those snowmobile trails, those groomed trails, they melt out, even though overall there's an increase in precipitation and even snow. We do have a difficulty, since we do have access to the individual days from the local models, so kind of the raw downscaled data. As Eric indicated, we're trying to figure out the best way to come up with the best proxy for snowfall out of the local model. So what we've done so far is our first take. It's just the percentage of the season where it's below 0 at night, and that's when snow tends to melt if nighttime temperatures are above freezing, and not refreeze. But we're trying to combine temperature with precipitation to come up with a better model of winter, and we're not there yet, but that's the next step.
I just had a thought for Eric Passler. The survey that you had sent out, do you have plans for engaging with those people and sharing some of that? I guess I'm thinking the people that are utilizing those parks and outdoor spaces, it would be great for those parks and the staff to be able to share that with them, because they're the ones that would be affected by this. I feel like that maybe that's some of the incentive for them to know these things.
Right. Yeah, no, I think that's a fantastic point. And we included at the end of our survey the option for all respondents to say either, yes, I would like a copy of the report and the results back once you're completed, no, or just leave it blank. And so we were for sure going to be contacting everybody who marked yes. And there were some other people that might have been adjacent to the people that we sent surveys out to that contacted us and said, hey, I got in contact with so-and-so over at such and such county, and I'd kind of like those results back too. And we are more than happy to make a lot of this stuff public and do conferences like this where we can kind of spread that awareness and just hope that word kind of keeps getting around to, like you said, those park and land use managers, but then also to the public and the people who might be engaging in these activities, because I think as much as anybody else, they're the ones who should know and should be up to date on what's going on, because it's their season that's going to be potentially continuously affected.
Thank you, Eric.
I would just echo some things that, and just add a little bit here that, you know, Ashley, you asked the question to me about seasons, and I would say the same thing's happening with our snow season. I mean, last year, everybody remember Halloween? There was, at least in southern Wisconsin, where we are in Whitewater, there was 3-4 inches of snow on the ground. And we have seen those shifts to not only later, you know, the kind of late February, March, even into April, increases in snowfall, but we've also seen a lot of early season snowfall events. You know, and last year when it snowed on Halloween here in Whitewater, I looked up and it had been since like the 1920s was the last time that Madison or Milwaukee, the two closest stations that had records for long term, had measured snow on Halloween or had snow depth. And those are two records that are commonly kept at these kind of major weather stations. Is so maybe it's a Eric and Eric, you know, it's an idea of thinking about, you know, what's controlling that snow depth and how that snow depth changes. And that's something we could potentially look into. And this is the first time I've seen Eric's presentation because our undergrad research day was canceled in the spring. So I was excited to listen to it. And, you know, all these ideas are sitting here running through my head, hearing the results of Eric's survey that I knew he was doing, but never heard any results from yet. So it was nice hearing it.
Yeah, thank you both so much for taking the time to join us and share your work. I feel like there is a lot, it's really intense, like these changes in records that you're sharing. It's, I know it can be deflating, but it's reality. So I feel like it's really important for us to be familiar with some of the data and facts that you shared. So thank you.